So you guys already know about functions. Is there anyone who does not know what functions are? Yeah, everyone knows. So I'll just reintroduce the whole thing. I'll keep it short. It will be like a one-on class because I think we should be done with functions by then. Um, does anyone want to tell me what a function is? Yeah, who wants to take this one? What's a function? Uh, Nikesh?
Yes, sir.
Yeah.
I know a little, sir. So we define a function using a keyword def.
Mhm.
The next function name. Maybe if we want, we can add parameters into that function, sir.
Yeah. But why do we use functions?
We can use instead of if we are doing the same operations repeatedly. For example, sum function. So we need to add two numbers means we can use sum function.
Yes, yes, that's correct. So in Python, there's or in general, there's this principle called DRY, DRY. Don't repeat yourself. So if you're writing code and you feel like there's some logic you will have to keep repeating, uh, you just write it inside a function, and then you can call it when you need to uh, run that or execute that logic. So that is the benefit of that. Uh, I can share my screen. I just want to cover the basic ideas of a function. Yeah, you should be able to see this. So, like I was saying, there's this thing called Travis, right? So, how do I write a function? Um, I use a def keyword, like Nitish said, followed by the function name, and then parentheses, and then a list of arguments. Yeah, list of arguments. This is not code. This is just a pseudo code, and then a colon, and then some logic, whatever. Um, error. Okay. Some code, and then if I want to just run that code, I just call the function by referring to it, and then passing in that list of arguments. This is basically it, right? Uh, okay. So let's go over the syntax. F is the keyword that lets you define a function. Then you have the function name. In Python, this name is usually uh, you guys, you must have heard the terms camel case or Pascal case or snake case. Does anyone know what these words mean? What's snake case? This is the word I mean. Anyone know what this means? So in programming, right, you have a bunch of conventions when it comes to writing these names, whether it be a function name or a variable name or a file name. So, and different programming languages have different conventions. So in Python, we follow the convention of snake case, where if you would have noticed, a lot of names start with lowercase words separated by underscores. Yeah, this is not like a rule, it's more of a guideline that is followed in Python. Other languages like Java, for example, they follow a convention called camel case, where you write variable names like this. You also have something called Pascal case, where it's like you have uppercase letters in each word, and you separate words by capitalizing the new word. So these are just conventions. In Python, a typical name is a snake case. So say I want to add two numbers, I would call it, I could just call it sum, but I could call it something like sum of numbers. And then parentheses, arguments. Do I need to give an argument or multiple arguments? No. Arguments are optional. It depends on what your function is trying to achieve. But in this particular case, I would give a list of two arguments, which would be a list of two numbers. So let's say int x and int y. And then you have colon. And now you indent by a tab. And what do you do now? You compute the sum. When I compute the sum, I return it. What's the return? So let's write it up. I use a variable here called int sum, and I calculate it as x plus y. And then I return x on sum. And now if I just call sum with say the numbers 5 and 3 and execute this. So to execute it, I can just print this. Print is also a function. So let's just do this. What is it going to do? It's going to do. Oh, sorry, I'm still stuck in C. You don't define the type. Just do this. I shall replace it. So I'll just run it. This int object is not iterable. Oh, sorry. Yeah. Okay. So what does this return keyword do? You can think of a function as a machine, right? This machine takes an input. So this is my machine. It is a machine. It takes an input. And it returns an output. So in this case, my function takes the inputs of my function are what? The numbers x and y. And the output of my function is a single integer called sum. Does a function always have to have an output? Who can tell me that? Is it necessary that my function returns something?
No, sir.
Okay. So if I just get rid of my return keyword, will this execute? Yes. But why would we want to call a function if it doesn't output something? Arvind, yeah, do you want to tell me, like, why would you call a function which doesn't return something?
Doing some internal calculations.
Yes, doing some internal calculations, doing some work, right? And creating some effect, creating some outputs. It might not be an output that returns back to whoever called the function, but it could be something like printing a line, right? So my function, I could have another function here. Just put this back. I could have another function here. Def print two numbers and give it the same list of integers and make it print the two numbers to the console. So, and let me call this print two numbers. I'll give it 5 and 3 and execute. So it just printed the numbers, even though it did not return anything. What if I try to do this? What if I try to print the output of this function? What will I, can someone tell me what will it print? Take a guess. I mean, okay, this is easy, right? If I just call print on the function and arguments, I know that the function is going to return basically an integer. So when I do this, I'm basically treating this function call as an integer. I'm just trying to print an integer here. But when I'm doing it like this, I'm trying to, I'm assuming that my function is something, right? So when I try to print that something, I should get something. I should either get an error or it should print something. So what will I, so who can tell me if it's going to be an error or not? Who thinks it's going to be an error? Take a guess. Let's run it. Let's find out. Has anyone seen this before?
Yes, sir.
Yeah. What is a none? Is it a string?
No return values.
Yes. So none is basically a special. Okay, Python has these things called built-ins. Okay. A built-in is, it could be a constant, it could be a function. So none is basically a special built-in which stands for nothing, right? In other programming languages, this nothing is called like null or whatever, right? None basically means nothing, the absence of a value. So when you don't return from a function, when you don't put a return keyword inside a function, it will return a none. So when you try to print it, it will print a none. What if I do this? Will it be an error? Like if I just use a return keyword but don't follow it up with a variable, like I did over here, is this a syntax error?
Still none will come.
Yes, exactly. So you can just do return and you don't have to specify a value. Not all languages work this way. Like if you take something like C or C++, the return keyword needs to be followed up with some variable. If you just do return, the compiler will error out. But Python lets you do that. It's flexible enough, so you can just say return. Now, one question you might ask is, why would you want to return or use a return keyword if you're not actually returning anything, right? Can anyone think of a scenario where you would want to do this? You would want to just do return without actually returning an output. Like what would be a use case for this? Oh, okay, we'll
Yes.
get back to, yeah. Go ahead. Sorry, go ahead.
To see the end of the function, sir.
Yes, I mean, there are sometimes situations where you want to stop doing work, right? It could be because of a number of reasons. One very uh, uh, one very common reason is that the inputs you send into the function, they are not uh, they are not like valid inputs for what the function is trying to do. So like over here, your function is trying to print two numbers. So you could have, like you might have seen in your problem sets, in your homework assignments, you might have seen some sentences like if it's a string, or if it's not a string, or if it doesn't pass this check, then treat it as an error, right? Or like don't consider that case. So basically, you could have a scenario where the uh, user sends a string, for example, into the function. And because your function is only, you are not handling strings, right? Your assignment was to just print or sum up two numbers. So in that case, you would first check if your inputs, if your arguments, x and y, are integers. And if they are integers, to continue doing the work. If they are not integers, you just use the return keyword to prematurely exit. Right, so this is something you will see if you just read a lot of Python code, you will see something like this. You will see something like, for example, here it could be like, so this is my actual print, right? This is the actual work I'm trying to do. So I could do something like if type of whatever, if type of x is not, int or whatever. And same thing with y, then return. And if you do this, it's going to just exit from the function. The moment control sees that, oh, there's a return keyword, it just goes back to the call. It stops working. Sometimes another convention is, and again, this is something that is left up to the programmer. Another convention is you just do if this, then nothing, or you basically put the print inside the if, right? And you check for the inverse. So if is int, then you print, right? This is also, so these are just different ways of achieving the same result. So you could first check for the error, and if it's an error, if the input is bad, you return, and then later on you do the work, or you put the work inside the if check. These are just two different ways of writing code. So okay, so far what have we learned? We have learned what the syntax of a function is. We have learned about arguments of a function, or args. We have learned that there can be one arg, there can be multiple args, a list of args. We have learned about the input-output aspect of a function, right? The args being the inputs. Just say args are inputs, and return keyword, which is basically the output. And we have also learned that sometimes you don't have to have the return keyword, so this is optional. And these functions do work, but they don't return something. In programming, these functions are, so there's this term for functions called pure versus impure. Has anyone heard these terms before in the context of functions? You can probably guess it. So a pure function is a function that doesn't create any side effects. So what's the side effect? Okay. So okay. A better definition of a function is, of a pure function is, a function is pure if every time you call it, exactly the same thing happens, right? So sum of two numbers. Every time you call sum of two numbers with some values of x and y, this function is guaranteed to return their sum, which is going to be the same every time you call it, right? So this is a pure function. An impure function would be something like this, because every time you call it, it will print a line to the console. So when it prints a line to the console, that action is called something. It's called a side effect, right? It's called a side effect because it is changing the state of your program. It's changing the state of the of basically. So if a user is calling your Python application, and your application calls this function, the user will see a line getting printed. So it's affecting the basically the result, the final result, what the user sees, right? So an action of that like that is called a side effect, and these functions are like they are considered to be different from what you would call a pure function. This is not to say that side effects are bad, right? When we say side effect, we usually mean that it's not something that you want, right? It's a side effect. It's not important. Sometimes we just call a function for its side effect. Sometimes we want to print something, right? We don't always uh, want to like get an output from the function, right? We want to call it for the side effect that it's having on the application. Side effects are good in that sense. So yeah, just yes, like some ways of like having like classifying functions, right? Just different kinds of functions basically. So what else? We have covered inputs, outputs. Uh, let's go back to inputs. Go back to arguments. Okay. So, what if you want to add a third number? Three numbers. All these arguments, right? If you supply, so for example, this particular function, it takes three arguments. So for example, if I do something like this, so okay, if I do something like 5, 6, 7, just add a z here. If I do this, this will work, right? It will add up 5, 6, and 7. Right.
It's a print statement.
What's that?
Print.
Oh, okay, I'm not there. Yeah, so this work. What if I do this? Will this work? Who thinks this will cause an error?
Yes, sir, it will cause an error.
Yeah, so let's try that. Okay, let's look at the error. Oh. Okay. What's the error? Traceback functions.py. So it says this is the line which caused the error. So the function call, and it says type error. Sum of three numbers missing one required positional argument z. So basically, the Python interpreter realized that I called a function which is supposed to take three arguments, and all three are required. None of these are optional. But I only supplied two arguments. So yeah, this is an error. What if I do z equals 100? Who thinks this will work? And have you guys come across this? Yeah, go ahead.
So this will work, sir.
Will work. Yeah. 111. So yeah, I'm not sure if you guys have seen something like this before, but this is basically what we are doing here is we are telling the function that, okay, I will send you a third argument, but if whoever is calling you does not give you the value of the argument, you use this default value. Yeah. So now, okay, this doesn't mean that I cannot send in a value of z. I can do something like 200, right? I can call this, and if I execute it, it like the function basically uses the value I actually supplied. But if I don't send this, the function will basically assign Z a default value of 100 and use that value instead. So this is called a keyword argument. Right? Now we are just looking at different kinds of arguments. This is a keyword or an optional argument. Yeah. Can I do this? Who thinks this will work or not? So I'm doing the same thing. My X and Z are required in this case, and Y is optional. And I'm just passing in 5 and 6. So ideally, what I'm expecting should happen is X should become 5, Z should become 6, and Y should be 100. Executed. Here the console. Okay. So this is the line which is failing, and what does it say? Syntax error. Non-default argument follows default argument. Okay. What this means is, if you have multiple arguments, and and some of them are required or non-default, and some of them are optional or default, you should follow this rule. You should put all the required arguments first and all the default arguments last, right? Because I mean, think about it. Python can't guess that you mean 5 should go to X and 6 should go to Z. It will try to basically parse this list in order. So it will try to give X the value 5 and Y the value 6. And now it's like, oh, I have a Z, but there's no Z. So of course it's going to fail, right? So this is an extra rule you have to follow. You have to always club the required arguments first and then the default arguments. This is still there. What if I want to send like 100 different arguments? How do I do that? I want to send like let's not, okay, forget 100. Let's say I want to send 5 arguments to a function. At the end, I'll quickly cover like a few good practices when it comes to functions, etc. But so we'll talk about this again. But how do I do that? Anyone? There's this thing called has anyone seen these before? Does anyone know what this is? Args and quarks.
No, sir.
Okay. So this is a special, like it's a special thing in Python. Basically, the point of this is, if the user wants to send a variable, an argument of variable length, right, or a list of arguments of variable length, so 5 arguments or 20 arguments or like 100 arguments, Python does let you do that. So if I wanted to call sum of 3 numbers, what I would do is, okay, I can and I can do something like this. 5, 6, 7. X is not defined. Let's print args. So I'm just printing args here. So it's a list of items and it's enclosed by parentheses. Who can tell me what this is? What's the type of this? I'm not sure if you have covered this, but you have covered lists, I think, and you have covered dictionaries. But have you seen something like this before? Do you know what a tuple
Set,
is?
sir.
A set. Yeah, this is not a set. Although, okay, I get why you said that. Sets also, I think, are enclosed by parentheses. This is not a set, although it can be converted into one. This is what's called a tuple. Okay, I'll just write it out. So variable args. Okay, so it's part of this tuple. So a tuple is basically, it's a sequence like a list, but it's enclosed by parentheses, and it's just a comma separated list. A set is basically a set is a very special data type because every element in the set is supposed to be unique. You don't have that constraint with tuples. You can have repeating items. But yeah, so this is basically a tuple. So you can reference specific items in this tuple by indexing, right? So you can do, if I want to print args, that's my args, but I can do print args, should print 5, right? So I can kind of index into items in the tuple, just like I would do with a list. With a set, there's another thing. In set, there's no order, right? In tuple, so if you convert, say, okay, usually you will do this a lot. You will take a list and you will convert it into a set. But if you convert it to a set, forget about the order. So whatever the order of items was in your list, that will go away, right? Because in a set, it's not important whether where the item is. What's important is the item there or not, right? So in a set, the question is always, is my element in this set, not where my element is in this set. Okay. So yeah, so we'll just so yeah, this is a tuple. So this can let you send in any a list of any size. So I could do, instead of 5, 6, 7, I could do 5, 6, 7, 8, 9, 11, whatever, right? Or I could just define a list separately, convert it to a tuple, and then send it. Yeah. So this is basically, I think I could also just send a list directly. I could also do that. So I could have my list, and then 3, 4, 5, and then I just send this. Let's see what this does. Okay, right now it's just going to print. Let's see if that works. Yeah. So this is what args was. It's oh, okay. So this is not exactly what it did. It converted. So it treats my list as an item in the tuple. So it didn't really do what we thought it would. It's basically treating my list as one item, and it's sending that in. So kind of different. Okay, and what are quads? Quads are basically if you want to supply a variable number of default arguments, right? So if I wanted to do something like this, 5, and then I don't. Okay, or let's do this. 2, 4, 5. A equals 10 equals 11. So I'm going to print args. I'm going to print quads. Let's see what these are. Yeah. So let's look at this output. Clear everything. So I'm printing args first. So args is basically this tuple 3, 4, and 5. Quarks is actually this. What is the type of this? This you must have seen before, right? Yeah, dictionary. Yeah. So basically, if you want to send named keywords, right? I could do this, and this dictionary could have any number of items. So I could have whatever. I could have dragon. I don't know, and that would also show up. So this is just a cool thing that Python lets you do. Not all languages have this. So what did we cover? We covered variable args, tuple, and key. Okay. So far so good. Is everyone so far following this?
Yes, sir.
Okay. What else do I have? What a list of topics I want to cover. Call stack. Can anyone tell me what a call stack is? So before that, when you call a function, what exactly is happening at the level of the program, at the level of the control flow, right? So that's where call stacks come in. Who has heard the term call stack? And does anyone want to volunteer to explain what a call stack is? Does anyone know what a stack is?
Yes, sir.
Yeah, what's a stack?
Sir, it is a type of last in first out, sir.
Yes, yes. LIFO, right? So
Yes,
you
sir.
have two types of data structures, queues, which are first in, first out. So whenever you push an item into a queue, it's also the first item that you pop out. So stacks are the opposite. So right now my stack is empty. I put one item on top. When I'm trying to remove an item, that is the item that I'll remove. So the item that was pushed in the last, that's the item that will be first out, right? So LIFO. So functions or function calls basically use the concept of stacks. So I'll give you an example. So I'll get rid of all this. This. Okay. Think of it like this. This is my Python file. This is my Python module. It has a function called function one. Yeah. And we don't care about the logic for now. We just have this function, and this function, it's in turn called a different function, function two. Okay, and let's define function two. Two. Okay, we'll just put a pass here. Okay. And function one is called by my main function. Main calls function. So this will work. It will not do anything, but it will work. So let's execute it. Okay. So what does this mean? Okay. I think I forgot to call the main function. So I'll just call this function the main body. So let's step over the program. Okay. What is the first function that my program will actually call?
Main function, sir.
Main, yeah. So when my Python module is executing, my module is the file, the control is with the module, right? When I call main, what Python internally does is it creates or it allocates some memory for that function. Okay, it basically allocates a chunk of memory. That chunk of memory is called the stack frame of that function. Okay, so when my Python function sees that, okay, this is a call to main, it will set aside this chunk of memory for me. Okay, now when I enter into main, that chunk of memory is basically an item in my stack. Okay, does that make sense? Just stop me if something doesn't make sense. Okay, so right now okay, I think everyone gets what a stack is. So right now my stack is empty, right? To start with, it has 0 items. I called main. What that did was it added or it pushed an item or a frame into the stack. So now my stack is basically the stack frame of main. All right. I go into main. The Python interpreter, it sees a call to function 1. Same thing repeats. My Python will basically allocate a chunk of memory for function 1, and it will push that into the stack. So now my stack went from empty to having one item called just empty, and then I pushed main into the stack, and when control goes into function 1, I'm basically pushing function 1 into the stack, or function 1's frame into the stack. So basically my stack now looks like this. Main, func 1. Yeah. Stack has 2 items because a new item has been pushed. The stack, the frame of main, that is still present, but it's currently waiting for the stack of just the most recently called function, which is function 1. So if you notice, the function that's called the most recently is at the top of the stack. Yeah. So right. Initially, my stack was empty. I pushed main, and I pushed a new item called func1. The main stack is still around. It's still there, but it's in a waiting state. My func1 stack is the active, sorry, my func1 frame is the active frame in the stack. It's the frame at the top of the stack. So I'm in func1. Func1 calls func2. What Python will do here is, you can predict this, it will push another item into the stack. So my stack now looks like this. So at the current point in time, my stack has 3 items. So for each of these frames in the stack, Python has allocated some memory. So all these memory chunks have been allocated at different places in the memory of my computer, and they are all allocated at the same time, right? None of them have been released yet. None of the memory has been released yet. So I'm basically okay, when we talk about our Python programs or programming in general, we talk about how much memory my function or my program is taking, right? Bigger programs take up more memory. So if I keep having functions that call other functions, right, in a chain, the stack will keep increasing in size. So the stack went from 0 size to 1 to 2 to 3. What happens here? Function 2 basically does a pass. Pass is nothing but, pass is like nothing, right? Pass will not do anything. It's just a dummy statement. So after function 2 does pass, control will, so there's nothing else, right? So control will go from func2 back to func1. What will that do? what will happen here is func2's frame is going to get popped out because func2 has completed its execution. So I don't really need func2's frame anymore. So now my stack has decreased by 1. The item at the top of the stack was popped out. It was last in, it's first out. So now my stack looks like this. So my func1 frame, which was previously in a waiting state, is now the active frame because it's at the top of the stack. So coming to func1, because func2 has completed, func1 also has nothing left to do. So the control exits from func1. And that does the same thing. It pops out func1's frame from the stack. So now my stack is back to size 1. And okay, main is also done by now because func1 has returned. So finally, what will happen is main frame will be popped out from the stack, and my stack will go back to be empty. Yeah. So this is basically what's happening is I keep calling functions in a chain, and my stack keeps like stacking up. Yeah, and the moment one function completes its execution, completes its work, its frame gets popped out, and my stack keeps going, becoming smaller and smaller. Yeah. So at the worst or at the most at the deepest point in my program, my stack was the longest, which was of size 3. Now, okay, alternately, I could do something like this. I could call func2 from inside func1, or I could do something like this, func1, and then call func2 directly from me. Can someone tell me what will be the max size of my stack if I do this instead of what I did earlier? So in the previous case, when I was calling func2 from func1, my stack reached a max size of 3. But if I don't do that, if I call func2 directly from main and my func1 doesn't call anything else, what will be the max size of my stack?
2, sir.
2, yeah, because it will go in main, it will call func1, func1 returns, func1's frame is popped out. The memory chunk of that frame is destroyed. And func2 now is the active. Now func2 will be pushed in, and then it will become the active frame and then popped out. Finally, I'm back to size 1, and then after main is done, back to size 0. Have you guys heard of recursion or recursive programming or a recursive function? Recursive functions, like if you have seen, for example, if you have seen, or if you have not, just Google this, recursive way to print the first n Fibonacci numbers, right? A recursive function is basically a function that calls itself. Usually functions call other functions. There are functions that call themselves. So my func1 can call func1 again. So these are basically special functions, and they are used to solve a variety of problems. So sometimes what can happen is, because of a bug, it could happen that func1 calls func1, then func1 calls func1 again, and this keeps repeating in an infinite loop. And what will happen here is, so can someone tell me what will happen? Like if I have, okay, if I just do this, right? Like a simple example of this, what I'm talking about is, okay, I have a func1, and I just do while, I think I don't even need to do this, but while true, sorry, main calls func1. Oh, okay, or I could just do this. While 5 through E. Or just this. What will happen here? Basically, if you just visualize it, my control, it first went into main. So my stack grew from size empty to size 1. Main called main, right? So main calls main. So when that happens, my stack, so when control goes to the second call of main, my stack goes to size 2. But this thing calls main again. So basically, I keep calling myself. So this my stack will keep on growing because there is no exit clause. There is no way to exit. I'm just stuck in a loop of sorts. So can anyone tell me what will be the end result here? A hint, it's a website, right? Usually when you're stuck with some programming question, this is the website you visit. Yeah, yeah. Recursion error, maximum recursion depth exceeded. Previous line repeated 996 more times. That means that Python imposes a limit on how large your stack can grow. So I'm not sure. It's possible that this number is something that you can modify, right? But I mean, my laptop can take a stack size of far greater than 996. Assuming my computer has like 16 gigs of RAM, I can keep calling a lot more times. But Python's like, okay, you kept calling yourself 996 times. There's obviously some bug in your program, so I'm going to throw an error. So this is a stack overflow. So I'm overshooting the maximum size of the stack, which is 996. Okay, this was recursion. So let's move on from there. What's next? Scope. We have covered call stack. Let's cover scope. Does anyone know what scope means? Usually we talk about the scope of a variable. What's scope? What does it mean? You guys know what it means? Or you might have heard the word before.
Sir, did you mean scope resolution operator?
Scope resolution operator. Can you give me an example of what that operator is?
So that assigns a variable. I do not know a correct definition here.
I think I've heard of that. Yeah, I'm also not very sure what that is, but I think it's related. I think it's the same scope that I'm referring to. Basically, the scope of a variable is basically the answer to the question, where can I call the variable from? Okay, so if there is a place, so say you define a variable, and there are places in the code from which you can call the variable, or you can, okay, you don't call variables, you call functions, you refer to variables, you reference variables. So any place that you can reference that variable from, that is inside the scope of that variable, right? And any part in the code or in your file or in your Python application where you can't call the or reference the variable from, that is outside the scope of that variable. Okay, so in the context of functions, let's talk about scope. Say I define a function and I define a variable, an integer inside it called x, and I give it the value 5, and I'll just print x. And this prints 5. This x is basically called a local variable. Why is it called a local variable? It's called a local variable because the scope of this function, okay, what does local mean? Local means around you, right? Like my local shop is a shop that is right down from my flat, right? So local means something which is in your home or close to your home. So a local variable is basically a variable created or defined inside a function, and it can only, its scope is that function. So if you try to call or if you try to refer to that variable from outside the function, so in this case, if I try to do this, print x here, this will fail because see my VS Code has this thing called it has this uh, extension called Pylance, uh, which can detect any error. I think you guys have also have this setup. So this is not allowed. If I try to run this, it will give me an error and that or an exception, and this thing is called a name error. Name x is not defined. So I was trying to access this variable x from outside its scope. Again, the scope being the function itself, right? So we have local variable. A local variable is a variable that you define inside a function, and its scope is that function. So if you try to call it from any place in that function, it will work fine. If you try to call it from outside the function, you will run into problems, right? Because you are kind of calling it from a place that is outside its scope, right? What's the other type of variables or the other type of scope? Something called global.
Global.
Yes, yeah, a global variable or global scope. The global scope or a global variable is basically talking about the module or the Python 5, right? So if I define an x outside here, x equals 10, let's say, and now I run this. So let's clean this up. And let's run it. Okay, so it prints 10 and then it prints 5. Why is that? So control comes in, x is 10. The scope of this variable, x is a global variable, and the scope of it is global. It's throughout that Python file. So I can reference it from anywhere in this file. That's why it's called global. Global means from anywhere, right? So yeah. So what happened is it first tried to print x. So it came in here. This is basically the scope of x, right? X, the scope of x is the whole file. So when I try to call print and give it x, print doesn't know about this x, right? Because this x only makes sense. It only has meaning inside this function. To this print, the only variable named x that is visible is this global x. So it printed 10 when it came here. Then I called main, and main defined a local variable called with the value 5. And when I do print x, it prints 5. One question that you could ask here is, why doesn't this print get confused between the local x and the global x? Does anyone know? I mean, it's reasonable, right? It's a reasonable question. When I try to print x here, I'm not telling Python which x I'm talking about, right? And technically, if the scope of this variable is throughout the Python file, the scope of this is also this function. So I should also be able to access this global variable from inside the function, because this function is a part of this file. It's a part of the global scope of this variable. Can anyone tell me why I can't print, why my print x here is not printing 10, but printing 5?
Recent value of x is 5, sir, in that function.
Recent value is, yeah, okay, Fine.
Finally updated value of x.
Yeah, you're on the right track. But a better way to think about it than recent versus first is so Python has an order in which it tries to uh, basically interpret or like tries to understand what a variable is. So the order in which it tries to uh, attach meaning to variables is uh, L followed by G. Okay, so whenever you try to reference a variable, right? So in this case, I try to reference X. It will first check if there's an X in the local scope, right? So it will first scan the local scope, which means it will first scan this function uh, for any definition of X. So remember, like 10 minutes back, we were talking about the stack frame or the function frame. So we talked about how every function has a frame, right? And the call stack is basically a stack of frames. So this frame, now if we don't have to get into too much detail on what exactly this frame looks like, but one thing that this frame has is basically a table of these variable definitions. So anytime I assign a variable inside a function, that mapping from x to 5 in this case gets stored in the frame of that function. So basically, the frame, if I just write out the frame of main, it basically has a mapping that says that attaches the name x with the value 5. Right? And globally also there's a mapping of these global variables. So the global, the table is all right now. It's like x is 10, right? Because I have a global variable which has the value 10. But there's also inside main, in the frame or in the stack frame of this function, there's a mapping, or in case there are multiple functions, in case I also have a y equals 20, the frame of this function has y is 20. So now if I think about this statement, print x, Python will first check locally if there's an x. So it will check inside the frame of the function. Is there an x here? It is able to find something named x. So when I print x here, it will print 5. If I get rid of x, what will get printed, do you think? So I have two prints in my code. So earlier, when I had a locally defined x variable and I run it, this print prints the value 10, right, which is the global variable, and this print prints the value 5, which is the local value. And we now understand why it printed the local before the global, because that's the order in which Python always checks. Just remember this: LG, local, and then global. If I get rid of this local definition of x, what do you think will be the output? Will it be 10, 5, or what?
10, 10, sir.
Yeah. So now, going by the same order, L and then G, what Python saw was that, okay, let me look up the frame of the function. Let me look up the local scope of this function. And it couldn't find an X. So now it will go to the global scope, right? This is always the order in which it checks. Local, then global. So there was nothing in the local scope, so it fell back. It went to the global scope and found an X and prints. And this prints the same thing because it can only check in the global scope, right? It's outside of all function definitions. So this is still 10. So this makes sense. So just remember this, whenever you have a bunch of global variables and a bunch of local variables, and this is a very common, like question, right? A very common question. Scope is kind of tricky. This is, you will definitely run into this, or you will definitely, your Python programs, or even this is not just applicable to Python, any programming language. The rules might differ, some of the rules, but whenever you see this, that okay, there are multiple function variables locally, globally, they have the same name, just go in this order. Just check local, then global. When it comes to reference. But sometimes I don't just want to reference a variable. I also want to update it. I want to modify it, right? So basically an assignment. So and with any variables, with any variable, you have two things. You can either read from them, is a reference, or you can write to them, which is a assignment operation. When it comes to reference, we go L and then G. What about assignment? So say I have X, I bring back my local X, and I y is 20. I'll just get rid of y. I'm not using it, and I do something like X plus equals 1. Yeah, and I run this. See what this does. 10 followed by 6, which makes sense. So it first prints this global X, which is 10. Then I call main. Main has this local X. When I do an assignment to X, when I try to update the value of X, it will automatically update the local X, not the global X. Right? So sometimes I don't want to update the local X, right? Let me get rid of X. Let me try to run this. Okay, so basically what I'm doing is I have a global X and I have this main function. Inside main, I'm trying to update X. Will X be, okay, will my program run or will it fail? Will this result in an error? So, okay, if we were going by the local and then global rule, so inside main, okay, there's this assignment operation. So it, okay, but going by that same logic, it will first look for an X locally, can't find it. So it will fall back to the global. And now it should try to just change 10 to 11, right? So I should see 11 followed by 11. Let's try it out. Now, it failed. What's the error? So this assignment is causing this problem, and it says unbound local error. Variable X referenced before assignment. So basically what's happening here is Python does not let you update a global variable or a variable in the global scope from the local scope. If you want to do that, you have to explicitly use a keyword called global. So you have to do this. If I inside my function, I at the top I do global X, or right before the assignment, I do global X. This is me telling Python that I want to update the global scope from the local scope. Let's run this. Okay. So what did it do? 10, 11. So print X, it first printed the value as it was 10. Then I went inside the function. Now, when Python sees this, it realizes that the local scope is going to try to update the global scope. So now it will let me assign to the global variable, and the global variable becomes X. So if I try to print X here again, I should see the same value again, 10, 11, 11. So the global, I have affected the global scope. I have updated the global variables value. Well, what if I keep X here, right? What if I keep my local X? So I have a local X. I'm doing global X. So I want to update the global X instead of the local X. Let's try this. I already know something's wrong because this has a, this has a red squiggly line under it. Let's find out what the error is. Okay, syntax error. Name X is assigned to before global declaration. Yeah. So this is not allowed. What if I do this? What if I bring this global, this thing after? .10.6.6. So basically, this is no longer defining a local X. The minute Python sees that, oh, global X, it forgets X is no longer allowed to be a local variable. So inside a function, you can't have a global keyword followed by a variable name and then have a local variable by that name. That is not allowed. Yeah. Just remember, when it comes to reference, local and then global. When it comes to assignment, you have to explicitly tell Python that I want to assign to the global variable through this keyword. Yeah. Does this make sense to everyone?
Yes, sir.
Okay. There's one other thing here, which is slightly, which is not very common, but it's still, it exists, called enclosing. Has anyone heard of this? Enclosing scope. So what it is okay. So I have a global variable. I have this global variable X. I have a function main. Inside main, I have a local variable X. I give it the value 5. Inside main, I can keep another function. I'll call it, whatever, foo. Inside foo, I declare another variable X. I give it the value 1. And X. And okay, I have to call foo. You can tell me the output.
10.1.5.
10.1.5. Correct. That's correct. So basically what happened here is I have the global scope, the global variable X, which has the value 10. I have this function, right? So this whole block of code is the local scope of the function name. So when I try to, when it comes to just go by, earlier we were going by L and then G, now go by LEG. Okay, so you will first check the local scope, then you will check the enclosing scope, then you will check the global scope, right? So enclosing scope is between local and global. I'll tell you what enclosing is. Think about it this way. My main function is enclosing my foo function. This, right? So, okay, for my main function, it's either local scope or the global scope. Yeah. For my foo function, there's the local scope. Then there's the enclosing scope. The enclosing scope is basically the scope of the function that is enclosing foo. And then you have the global scope, right? So now there are 3 levels of scope. So when I try to print X here, the only scope is global, so it prints 10. Then I call main. Main defines an X, so this the scope of this X is the local scope of main. So basically this, whatever's indented inside this. Right? Then I have another function inside main called foo. Foo has a variable called X. For this function, the local scope is the body of this function. So when I try to print X or reference X inside foo, let's go by this order. Is there an X in the local scope? Just look at the print statement. What is the local scope of this print statement? This function, is there so basically in the stack frame of foo, is there a definition of X? There is. So it will print 1. So when I call foo, that's what it does. When control goes back outside foo to this print statement, now go by this again. What is the local scope for this print statement? This function, right? So is there a local X? Yes, there is. Its value is 5, print 5. Then control goes back out to my main module, and okay, there's nothing else. So an extra layer. What if I get rid of this X? What will be the output? So earlier it was 10, 1, 5. What will be the output?
10, 5, 5.
Yeah. So I think okay, it makes sense to everyone. Now again, just go by LEG, right? Go by the leg rule. Now when you print X, there is no X in the local scope of this reference. So it goes to the scope outside that, which is the enclosing scope in this case, and it's able to find an X. So it prints 5, and this will still print 5. This will still print 10. What if I do this? What will be the output?
Ten.
Yeah, because again, just evaluate this reference. This is a reference. Evaluate this. There's nothing in the local scope, nothing in the enclosing scope. There is something in the global scope. So that's what it looks like. Yeah. Now we talked about reference and assignment when it came to local and global. Let's talk about assignment in terms of enclosing scope. If I want to update this X from inside this function, what do I do? I'll bring this back. So earlier we talked about updating the global scope from the local body of the function. Now I want, I might want to do two things. From inside foo, I might want to update the global scope, right? So I know how to do that. I do global X. I'll do the same thing, X plus 1, print X. What do you think the output of this will be?
Sir, 5, 11, 10.
5, 11, 10. Okay. Let's see. Ten, 11, 5. So let's see what happened. I think we're on the right track, but we just forgot about this. So the first thing that is executed is this print statement. So this should still be 10, right? Because it's the first thing that's executed. So 10. This makes sense. Now I go inside main. I define a local variable X, give it the value 5, have this definition. And I call foo. I go inside foo. I'm using the global keyword. What this will do is it will make Python interpret this X as the global variable. So when I do x increment by 1, I'm incrementing the global variable by 1. So I'm changing the global variable from 10 to 11. And now when I try to print it, I'll print 11, right? This x is still global. Control goes back out. Over here, there's no global keyword in main, right? So when it sees this print, it's a reference. So it will go by leg, local. So it will update or it will reference so if I just do x plus equals, should have probably done this, x plus equals 1, and 10, 11, 6. So 10 is printed here. Global x is updated by incremented by 1 here. So it changes to 11 is printed here. Now when I come at this x plus equals 1, this x is still, there's a local x, right? So this local variable is what's incremented by 1. So when I print this, I get 6 because this local variable was updated, not the global variable, right? And fine. So yeah, this is the final print, 6. What if I want to update this x from inside foo? Can I do that? And how do I do that? So basically, I'm trying to go against the LEG rule, right? When I for assignment, if I specify the exact scope I want Python to look at first, I just use a keyword which is the name of the scope. So if I want to make Python use the global scope variable first, I use the global keyword. In this case, I want Python to use the enclosing scope variable instead of the global scope, right? So the keyword for that is non-local, right? Well, inside foo, when I say non-local x, non-local is basically enclosing. So when Python sees this keyword, it will first look in the enclosing scope. It will not look in the local or global scope. Sorry, not first. It will only look in the enclosing scope. And it sees a variable in the enclosing scope of this statement, right? And that variable has a value 5. So what should this print? See, 10, 6, 7. So 10 is printed here, easy. Now foo, non-local x. So now x becomes basically this. So when I do x increment by 1, I'm incrementing the enclosing scopes variable, this x by 1. So I'm changing this to 6. When I print it here, the value here is 6. Okay. Now when I go back out, x increment by 1 again, this is going to increment this local variable from the perspective of this statement, which is this. But this value has become 6 inside foo. So now when I increment it, 6 becomes 7. This prints 7, right? So LEG. And finally, there's one other layer called B. B stands for built-in. B stands for built-in. So Python has a bunch of like built-in names, variable names, and functions. Like if you want to, I think there's a way to get a full list of the built-ins. I think it's old built-ins. Just do this. Print. Okay, so this is a object. So okay, you guys probably have not covered Python objects before, but if you want to print all the members of an object, all the attributes of an object, you use a dir method. So I can do print dir. So yeah, this is list. Let's copy this. See what. Yeah. Okay. So basically, all these are basically just special built-in names, and Python actually lets you override these. right? So sum is a built-in method which sums up two numbers or a list of numbers. So Python will actually let you, yeah. So so far we have been talking about scope for variables, but the same thing applies to functions. Functions also have scope, right? In more complicated programs, there's scope of a function. So Python lets you basically, so Python actually lets you define your own sum function, which can do something totally different, right? So I can actually do something like this. I can define. So if I just use sum as it was, right? I just do sum of 1 and 2. Put an interval. Sum of 1, 2. What this function, this built-in function does is it takes a sequence of integers, in this case 1 and 2, and it adds them up. But I can do this. In my program, okay, if I do this print sum of 1 and 2, I just get rid of these prints. So I should get the output. I should get the output. P. But what I can do is I can define something. I can define a function called sum, which doesn't take any arguments, and it prints take sum. Yeah. Let's see what this does. Okay, I should probably return something. Return a string called it's should probably be an error. So I'll just do this. I'll use the args thing we learned earlier to let it take a arbitrary list. Try this out. Fake sum. So basically, what I did was I redefined what sum means. Right? So Python will go by the LEGB rule. It will first look for this function in the local scope. There's nothing. It will then look for the function in the enclosing scope. There's nothing. It will then look for the function in the global scope. It does find it, right? It will check the built-in scope at the end. So if there was no global definition of sum in the global scope, it would have gone finally to the built-in scope and used the built-in definition of sum. And that would have been the expected thing, right? But Python actually lets you like override the built-in variables and functions, right? And it lets you like make that mistake. So usually it's not recommended to change or use the same name as these built-in names, right? Because that can create unintended effects. Like say someone is new to Python programming and they don't know that there's a built-in called sum. They might try to write their own function called sum. And then later on, someone can come and be like, oh, I want to add a list of numbers. Let me call sum. And then they end up calling the user-defined sum instead of the built-in sum. So this is something that can happen. So that was scope. Does everyone understand what I was talking about? Is everyone on board? Did you understand how scope works? So any doubts that you have, just go by LEGB, right? Local scope, enclosing scope, global scope, built-in scope. You will very rarely come across enclosing and built-in, but it's good to know. But remember local and then global always, right? That you will come across a lot more frequently. So did everyone understand that?
Yes, sir.
Okay. What are the topics I wanted to cover? We covered args. We covered return values, we covered call stack, we covered scope. I think all that's left is good practices. Okay, in Python in general, there's a lot of good practices or best practices. When it comes to functions, can someone tell me what's a good practice? You just give me any example of like a good thing to do, like a good style choice to make. Any example, doesn't have to be important, just anything. Say you are implementing, say your task is implement a function to do XYZ, right? Do whatever. What is something that you will keep in mind when doing that? Just something very simple that comes to your mind. Now, you guys might have already, okay, you know that putting helpful comments in the code is a good practice, right? So for functions specifically, there's this thing called a docstring. Does anyone know what a docstring is? You can already see examples of this in the, okay, not here. Just get rid of it. I'm just defining a function, calling it. This is a docstring. Docstring basically stands for a documentation string. So one example of a good practice would be that whenever you write a function, you put some documentation explaining what that function does, what are the arguments it takes, and what is it that the function returns. The benefit of doing this is that if someone is reading your code, they immediately get what the function is trying to do, right? So far, we have only seen like, okay, we have been trying to understand these key topics. So we have only been dealing with 1 line or 2 line or like, 5-line functions, but functions can grow to hundreds of lines and they might be doing very complicated things, right? You could have a function that takes, that reads an image file and then it basically does some image processing on that image and then it writes the processed image to some file system, right? You could have like a function that takes in, some very large data set, and it runs some ML algo on that data set and extracts features from it, whatever, right? You can have like functions of very high complexity. So if you keep a docstring in the function, right? A docstring could just look like this. This function does this work, and then say it takes args x and y. So you just have arguments x, int, number to add. Okay, assuming this is a sum, right? Whatever. Y is also an int. Second number to add, and then returns or this return int sum of the two values. Right. Going back to the first function we had written, this would be a good docstring. It's clearly telling the whoever's reading the code what the function is doing, what is it taking in, what are its inputs, and what are its outputs, right? if you also, okay, you guys use VS Code, so this is another benefit. If you put a doc string in the function, right, VS Code can actually read the doc string. VS Code knows what the doc string is. It reads it and it gives you a nice preview, right, of that function. So here VS Code saw this comment at the top of the function, so it extracted it, and now it's giving me a nice little peek of the function. So it's telling me that this function does this work, arguments X, this, Y, this, return this, right? So this is a good practice. What are other good practices? Gautam, do you want to take this? Do you have something in mind? Or Shri?
So I don't have any.
Okay. Another good practice would be that ideally one function should only have one main task, right? I think Nikesh said this at the beginning, that the point of a function is reusability. So if you have one function that does 20 different things, it's not very reusable, right? Because sometimes I might only want to do 5 of those 20 things. So if you're writing large Python applications, right, if your Python application is like multiple modules, and then you use the standard library, you use pip packages, and you are doing like lots of intensive work inside these functions, it's a good practice to split up the work into logical buckets, and for each logical bucket you outsource it to a function, right? And if you just plan out all the work that your function needs to do, and this process is, by the way, called refactoring. That's a word you guys might have heard, that refactoring code is basically taking there's a word called spaghetti code, right? Like spaghetti is basically like chow mein, right? So spaghetti code is basically a Python file where, okay, I'll just show you what spaghetti code is. So this is a spaghetti code. So I have written this function. I'm like, okay, functions are a good practice. So I make a function, and inside my main function, I just do like thing A and then thing B, and then my function is basically just like a big wall of text. I'm just doing like 40 different things. I'm basically doing some arithmetic operations here. I'm doing some file. I'm reading from a file here. I'm writing to the file here, right? Just give you an example. So my function is basically long and flat, right? This is spaghetti code, right? Because if someone is trying to read this, it's like everything is mixed up in this pot, right? There's no kind of grouping that, okay, I have this task one, so over here refactoring would just be this. You take basically task one, you move it out to some other function, right? You write a doc string for it, and then you do this, and then same thing, you repeat the same thing with the other code that your main is trying to execute. So, and this is like a very general guideline. If someone gives you a homework assignment or some exam question or whatever, right, you have to make a real world application, spend the most time, right, before you actually start coding, spend like a really long time just organizing all the work that you have to do into these logical groups, right? That I have to do this work first. This work should create this output or this side effect. Both are fine. And after I'm done with this, I then move on to this, and then organize everything into its own function. So think about what you're trying to do. Think about certain things you might want to keep reusing, right? So usually lots of real world applications, they have a layer called utility functions, right? Utility functions are just functions that do useful things that you have to keep doing again and again, right? So basically code that is very reusable. So these utility functions are called by every other layer, right? Because they just help get the job done. So you have to basically think of your program as like a tree, right? You have the main trunk, then you have branches shooting from it, right? And each branch then splits up into other leaves or whatever, or other branches, right? So you have to like think about the overall shape of your program, and your final goal should be to not just write a program that works. It should also be a program that is fun to read, right? If someone's trying to read your program, they should have a good time. They should feel good. It should be like reading a nice story. It should not be like just reading that there's just like this one function and then it's just doing 40 different things, right? Because if you do that, even if you put comments, even if you put doc strings, it's just not going to be very readable. And I think I talked about this in my previous class, that code is written to be read, right? Any code that you write, a code that is written by one person will be read by 100 people, right? It's 1 to 100. So your code should be readable. It should be clean. It should be logical. It should make sense, right? It should be split up into all these layers, and those layers should make sense in the context of the overall code. That is just in general a good, and then all these individual good practices are just basically that, right? So doc strings are helpful because they make your program readable. Refactoring is helpful because it makes your program readable, etc., etc. Yeah. So there's like a lot more examples of good practices. What I'll do is, I'm not sure if you guys have heard of PEP, PEP, right? Has anyone heard of this? Does anyone know what PEP is? It's basically a style guide for Python, right? So just Google PEP, right? It's basically a set of rules which are best practices. So, like, if you want to just grow as a Python programmer, one useful thing would be read one PEP rule a day, right? Just because one PEP rule is just like a statement. There's a PEP rule saying that, put doc string inside a function. That's a rule, right? So one rule is like, it's like reading reading the horoscope. It takes like a second. So just Google PEP and read one rule a day. Or like there's like a bunch of blogs which are just summarizing the main, the most important best practices for Python. Because once you understand that, everything will start making sense. Okay, why does Python let you override the scope? Why does Python let you do this? Why does Python let you do that? It will all kind of start making sense. Okay, so if I find some useful links, I will send it to you. The PEP style guide is basically here. It has its own website. I'll just drop this in the chat. So take a look at it. Just browse it. You don't have to read it like a book, but it's just like a nice thing to just browse whenever you have some free time or whatever. So just do this, yeah. So I could talk about more good practices, but we are already pretty late. So I'll leave it here. Does anyone have any questions? Or does anyone want me to cover something? If I don't cover it today, I could cover it quickly for 5 minutes next week. Let me know, okay? And yeah, we'll stop it here. Hope this was useful. Hope you learned something. Okay, so thanks for coming. Thanks for attending the class. And I'll see you next week. All right. Okay.
Okay, sir.
All right. Bye, Nikesh. Bye, Arvind, Raghav,
Bye,
Shri,
sir.
Gautam, Rohit.
Thank you, sir.
Sure.
Bye,
Thanks.
sir. Bye, sir.
Bye.
sir.
Thanks a lot. Have a good night.
Thank you, sir.
Thanks. Bye.
Thank you, sir.